All right, we found the solution to A using the method of integrating factors. The second equation in our system was this equation where B is written in terms of A. So we can now write that, because we have A, we can plug in what we have for A into this equation. So that's 3 over 100 times, now A is 300 minus 290 e to the minus 3t over 100 minus 3b over 80. So that is our differential equation for B, but when we substitute in what we had for A, there's no more A's in here. So this is now a single differential equation for B, and we can go ahead and solve it as we would want to solve it. I will do it with the method of integrating factors. So plus 3 over 80b equals all of this right-hand side. Let's see what we've got here. 100 goes into 300 3 times 3 is 9. And then minus 3 times 29 over 10 e to the minus 3t over 100. So I've rearranged things so that I can use the method of integrating factors. The integrating factor that we have, mu, is e to the integral of 3 over 80. So that's e to the 3t over 80 for our integrating factor. Multiply everything through by the integrating factor. We have b e to the 3t over 80 prime equals 9 e to the 3t over 80 minus 3 times 29 over 10 e to the minus 3t over 100 plus 3t over 80. Whew, okay. And I have done the common denominator here, and this turns out to be e to the 3t over 400. So you can combine those with the common denominator, and that is what you get if you do that. So we're now ready to integrate both sides. Right, so we integrate both sides. This is the method of integrating factors, and we have b e to the 3t over 80. The integral here is 9 times 80 over 3, e to the 3t over 80. We have minus 3 times 29 over 10 times 400 over 3 times e to the 3t over 400. And then we have a plus c. So that is integrating both sides. We are only a few steps away from the solution now. Let's keep going. All right, this is our intermediate step of the method of integrating factors. We have integrated both sides, and this is what we now have. There's some simplifications that can happen here. 3's can cancel, a 10 can go into 40. We can cancel a 3 here. And the next step is to solve for b, and so we do that by multiplying everything through by e to the negative 3t over 80. So what we're going to end up with is a b of t on the left-hand side equals 240, 3 times 80, minus, what do we have left over here? 29 times 40 times e to the 3t over 400 minus 3t over 80 plus c e to the minus 3t over 80. So this is our solution, and the only thing left to do is plug in the initial condition. We have b of 0 is 5 pounds of salt were initially in that tank. So that is 240 minus 29 times 40, e to the 0 is 1, so plus c, right? And so c is going to be 29 times 40 minus 240 plus 5. So punch that into your calculator. We have our value for c. You can plug that in here, and then this is our solution, b of t. So from start to finish, we had to set up this system of differential equations. We noticed that A was not coupled to B, so we solved the equation for A using techniques that we already knew, the method of integrating factors. From there, we are able to take what the value for A, plug it into the second differential equation for B, and then we can solve the differential equation for B. Again, using integrating factors. Got pretty messy along the way. Like these are some mean numbers that we had to deal with arithmetically, but that is the solution flow here. Set it up, solve the first equation, plug the solution into the second one so that you can then solve the second one. And then together, the solution, you would write it out as A of t equals and B of t equals whatever those are. And we'd have our full solution, and we would know how much salt is in each tank at any moment in time.